Assalamualaikum and good morning to Madam. We are Group 5 from BMMV S1/1. We'll present our assignment about conduction graphical analysis on heat transfer. First of all, my name is Batrisha Nur Saadah binti Mat Sharin and I will discuss about introduction of fin. Number 1 is a fin is addendum attached to a larger body or object. It is a thin part that typically functions as a foil, which can make a lift or thrust. This means that this fin is a small object or product attached to another body or larger object such as a radiator in a car. Secondly, it is provide the ability to stabilize motion when traveling in medium like water, air and other fluids. Thirdly, fin commonly used in heat exchanging device such as radiators and CPU. Like I said before, it's usually used in cars such as radiators. For our assignments, fins are located on the outdoor portion of an air conditioner near the compressor. These air conditioner fins are a part of the condenser that assists heat in moving away from the air conditioner so that the heat spread out faster.
Assalamualaikum, my name is Dayang Masita binti Abang Abdul Razak and I'll be presenting on the part of design and result analysis. So for design, we have two design. The upper one is a design 1 and the lower one is a design 2. So this design is a fin surface that come with a base of 40 mm times 40 mm and the convection is 5.03, come with a heat flux with 1500 watt per meter squared. So we choose the ambient temperature of this design is 303 Kelvin. So this design concept also known as an extended surface, and these fins are mostly used in heat exchanging devices such as radiator in car, CPU in computer, heat exchanger in power plant, also in aeroplane industries. So this is a design 1 in a layout. So it comes with a measurement. So in a gray color is a isometric view. Next to it is a top, below is front, and next front is a right or left view. Already being analyzed in a SolidWorks simulation. So in the middle is the results of temperature in Celsius. As we can see, the hottest is 63.4 degrees Celsius and the lowest is 63.1 degrees Celsius. So as I mentioned earlier, this fin can be used in a radiator. So a normal range for a radiator operating engine is in the range of 60 degrees Celsius until 105 degrees Celsius. So which is we cannot exceed 105 degrees Celsius or else we can damage our engines. So this material is made from 6061 aluminum alloy. So why do we choose aluminum alloy? Aluminum alloy is a material that can resist heat until 600 degrees Celsius, and also it has lightweight and have a good relatively in a thermal conductivity.
Assalamualaikum, my name is Ashraf Arushdi and I will explain about the second design that our group decided to make. So as you can see, the length and width is equivalent to 40 mm and the height is 8 mm and it is made of copper. As for the simulation analysis design 2, the highest temperature is 43.565 degrees Celsius and the lowest will be 43.347 degrees Celsius. This fin design can be used in CPU such as computers, laptop and so on. Normal range of operating temperature for CPU is 40 degrees Celsius to 65 degrees Celsius and it is made from copper. Copper material can withstand up to 1084 degrees Celsius and has a good thermal conductivity, but copper is heavier and more expensive than aluminum. That's all for me. Thank you.
Assalamualaikum and hello everyone. My name is Nadra Fatira and I will present to you the discussion of this project. First of all, heat sink plays an important role as a cooling device as to reduce the heat generated when the equipment parts are running. Thus, the mechanical equipment components cooling to increase the operating life of the equipment. For this assignment, we chose two different materials which are aluminum and copper. Aluminum is known as the most common material for heat sinks. In particular, extruded aluminum heat sinks fit the needs of most projects. The metal is lightweight and has relatively good thermal conductivity, while for copper, it has even better thermal conductivity than aluminum and it is preferable for higher heat transfer rate application. For aluminum, we use aluminum alloy 6061 and it is commonly used with thermal conductivity values of 167 watt per meter Kelvin and is typically used for machine heat sinks. The values are depending on the temper of the alloy. While for copper, it has even better thermal conductivity values of 401 watt per meter Kelvin than aluminum as mentioned before. But there are drawbacks for the weight and cost. Copper has around twice the conductivity of aluminum, but denser and more expensive than aluminum. Copper's high thermal conductivity means the temperature across the heat sink will be more uniform. This can be advantageous since the extremities of the heat sink will be warmer and thus more effectively radiating, and hot spot attached to the thermal load will be cooler. There are pros and cons for both materials. Copper has a higher thermal conductivity and therefore is superior to aluminum in processor cooling. Copper is better at conducting heat than aluminum, but aluminum is able to radiate the heat into the air better than copper because of its lower density. Next, they have a different temperature for both designs. For design 1, it has a higher temperature because it has a smaller distance of fins, which makes it less heat removal. While for design 2, it has a lower temperature because it has a bigger distance of fins, which makes it more heat removal. So what we can conclude that by increasing the length of surface area, it can reduce the temperature of the heat sink. The amount of heat removal is directly proportional to the surface area of the heat sink.
Alright, I will explain about the conclusion for our task. The conclusion is we choose aluminium fin because the cost is less expensive than copper. Besides, aluminium has the ability to absorb heat more and it will cool faster because it is less dense than a copper. Besides, it obtains a lighter heat exchanger than the copper. Lastly, aluminium fins have more design flexibility and easy to recycle. So, aluminium is the best choice for our product. That's all. Thank you.